This is Geometry Section 1.3, Midpoint and Distance Formulas. So to understand a midpoint, you pretty much need to know what a bisector is. They kind of go together. This right here would be a bisector for segment AB. Could we bisect a line? No. Remember, a line goes to infinity in both directions. Where would you find the middle? Technically, the middle would be anywhere because you've got the same distance on either side, infinity. So there is no midpoint for a line. What about a ray? Same problem. It goes off to infinity in one direction, so you can't ever find a midpoint. The bisector can be a line, it could be a ray. I did it again. Gee whiz. I need someone to stand next to me with a board and smack me upside the head every time I say line, when I mean segment. What I first drew here was a segment bisector, and that's legal. A segment can be a bisector. A ray can be a bisector. A line can be a bisector. And if we didn't have any of that, a point could be a bisector. And in fact, really hard to draw, but we could also have a plane that just went right through the middle of this line. If this line shot through a plane here and intersected right in the middle of the segment, that plane would also be a bisector. Lots of things can be bisectors. What they have to do is divide the segment into two equal parts. If M is a bisector, what this really means is, in fact I can just write it out. M is bisector. I bet your 4-year-old cousin writes better than that. But can he figure out midpoints? M is a bisector. That automatically means that AM, this is the length of AM, equals the length of MB. Or, remember our section on congruence, we could have written is congruent to segment MB. These pretty much mean the same thing. If AM is congruent to MB, then AM and MB have the same length. Now that we know what a midpoint, M, and a bisector is, how do we find, let's say, the length of AM, or exactly what this point would be? For instance, suppose we had a number line. Let's just pardon me, forget that one. Let's start with a number line. Now suppose we have a line that goes from -2 to +4. This is one form of the midpoint formula. It's very simple, especially on a number line. All we have to do is add the two numbers, because it turns out the midpoint here, let's say A was -2 and B was 4 on this number line here. The midpoint is in fact the average of these two values. That's right. So we have 4 plus a -2. Don't forget to do it right. Don't write 4 plus 2. You'll have a problem. And you divide that by 2. And that, of course, is 1. 4 plus a -2 is 4 minus 2, which is 2, and 2 over 2 is 1. Does that make sense? Well, let's see here. From the point 4, we go 3, 2, 1. It's about 3 units that way, and from here we go 1, 2, 3. 3 units that way. Well, yes, this would be, if this is -2 and this is 4, then we got 3 units over here and 3 units over here. And that is, of course, what we mean by midpoint. So, for 3 numbers, that doesn't work. You add up 3 numbers, take the average. It's hard to call that a midpoint, although it does have usefulness later on in mechanical engineering and lots of other things. So don't discount this idea for more than 2 numbers. For now, we're only going to use it for 2. Pretty simple, right? The midpoint, you're just finding the middle point of the line segment. Could hardly be easier. So what was the formula we used here to find this midpoint? Well, we can write it in general terms as, if we have numbers on a number line to identify these points, we can write it as endpoint 1 plus endpoint 2 divided by 2. That is the general formula. And we're going to extend that formula now for coordinate planes. Suppose the line doesn't just lie on the number line. Lines don't have to do that. They might just take off that way. Now what do we do? It's a little bit different for that, isn't it? Well, but it's not too tough. Let's watch what we do here. Suppose our line is in a coordinate plane. What then? So we have our axes. Here's the y-axis. This is the x-axis. And we have a line here. And we're going to figure out what are the coordinates of this midpoint here. Well, first we have to have endpoints, the coordinates for the endpoint. We'll call them x1 and y1. This endpoint here. And for the other endpoint, well, let's call that x2, y2. And let's guess that this is about the midpoint here, right? Well, remember, x is the coordinate on the x-axis here. Y, that's the coordinate on the y-axis over here. Same thing here. x2. That's the coordinate down here. I could label these x1 and x2. And over here, what do we have? Well, this is y2, and this is y1. Now, to find this midpoint here, what do you think we're going to do? It's not really that tough. We're going to find the midpoint of these two. What would that be? x2 plus x1 over 2. It'd be right about here, wouldn't it? And if we draw our little imaginary line straight up, this would be the x-coordinate for the midpoint. And for y, well, what's the midpoint of this section right here? How about y2 plus y1 over 2. Now what we have, this part here, is usually referred to as x sub m, or x sub m. That's the x-coordinate for the midpoint. And this is y sub m. So if you see it written this way sometime, that's what they're asking you for, is the coordinates of the midpoint. And you do that by finding the x-coordinates for the midpoint, which is the midpoint of the x-coordinates, and the y-coordinates for the midpoint, which is the midpoint of the y-coordinates. Pretty simple, really. You're just applying the distance, or pardon me, your midpoint formula that we had for the number line over here. This midpoint formula. This one here. We're just extending it. That's all. twice, and now it works for a coordinate system. Cool, huh? Now let's stick with the same line. Suppose this endpoint here, x1, y1, we can call that A, and we can call this last one over here B. And the question is, what is the length of AB? We found the midpoint of AB. We know what the endpoints are. In theory, we're just calling them x1, y1 using general variables, but we're assuming we actually have numbers for these at some point, so we can do this. So what is the length of AB? Well, this is a good one. And it's one reason I tend to always write the second one first, because as you bounce back and forth between the midpoint, well, forget that. It's not really important. I just do it because that's what I'm used to doing. It's not really going to matter. You can do it either way you want. What is AB? Well, you're going to take x2 minus x1. Don't add them together this time. And you're going to square it. And then you're going to add y2 minus y1, and you're going to square that. Now you've added up these two squares. How in the world is squaring something going to give you the actual distance? Well, we're going to take the square root of that. So there's a little bit of sense to it. We squared these things, we added them up, and then we took the square root, and you know what? That will actually give us the distance from here to here. Hard to believe, but it's true. So let's try it with real numbers. Here we have a grid. We have the point 1, 3, and let's call it A. We have the point 4, 2. We'll call that B. Our question is, what's the distance? And the midpoint from here to here. Let's compute the midpoint first. What would it be? Well, it's roughly in there, right? You can eyeball it and get kind of a half an idea. But that's not good enough. Pardon me, we need an actual number. And how do we do that? First, we find the midpoint of x. And we do that by finding the average, remember? 4 plus 1 over 2. That's 2.5. And that is x sub m, the midpoint of the x coordinates. And when I drew the dot, it looks like about 2.5. I'm guessing we're on the right track here. Now what about this? 2 and minus 3. Well, we do pretty much the same thing. 2 plus minus 3 over 2 minus 1/2. We have 2 minus 3, that's minus 1 over 2, which is minus 1/2. Does that make sense? Well, let's see here. We sketched it in, and that looks like about minus 1/2. And that equals y sub m. So, this point right here is the point 2.5, comma, minus 1/2. That's that point right there, which we can label now as m. That is our midpoint. See? Not tough at all. Now let's try our new distance formula and see if we can figure out how long this line is. I bet we can. How did we do that? Remember. And you just have to keep them in order. Actually, don't have to do that, I guess. So whether you subtract 4 from 1 and then square it, or subtract 1 from 4 and then square it, the difference is going to be a negative sign, but when you square it, the negative sign will become positive if there is one. So, either way you do it, you'll get the right answer. Cool, huh? Let's try it over here. We get 4 minus 1 squared plus 2 minus a minus 3 squared. And of course, we're going to take the square root of that. And what is that? Well, 4 minus 1 is 3 squared plus 2 minus minus 3 is 5 squared that equals the square root of 9 plus 25. That's the square root of so what we get for an answer here is the square root of 34, which is 5.8, roughly. Does that make sense? Always take a quick look at your answers when you're doing these things to see if your answers make any sense. For instance, if I got 58 or 9.3, well, we'll go back and look at the actual numbers and see if that makes any kind of sense. Does it? Well, let's see here. We've got a x-coordinate of 1 here and 4 here. So we've got 3 units this way. We've got minus 3 here and minus 2 here, so we've got 5 units this way. We've got 5 units up, but off a little bit to the right. So it stands to reason this length to be a little bit more than 5, and that's what we got, so it makes sense. I admit that's not the perfect way to come up with an answer, but you can always take a look and see if your answer makes sense to you. If you get like 2.8 or 11, if you do what I just did, you probably get an idea that that's not quite right. Now let's try another one. Okay, here's another good one. It's going to be 2 parts. What we're going to do is we have the endpoint here. We have the midpoint. We have one endpoint. What we have to do is use our midpoint formula to work backwards and figure out what this endpoint must have been. And then we'll find the length of AB. We can do that. So let's start with our midpoint formula. And what would it be? Well, what we have is x plus 1 over 2 would equal the x-coordinate for the midpoint. With me so far, right? And what is that? Now it's equal to 2. So we multiply through by 2, and what do we get? X plus 1 equals 4, or x equals 3. And the way I drew it, it's pretty close. Okay. What about the y-coordinate? Well, let's do it again. Pretty much the same thing. We'll say y plus 4 over 2 is our y-coordinate for the midpoint, which in this case is equal to 1. Once again, just multiply through by 2, and we get y plus 4 equals 2, or y equals minus 2. Does that make sense? Well, yeah, actually, it looks about right. So now, what we have here is that the coordinates for point B are 3, comma, minus 2. Now that we have this, A and B, let's do it right over here. We can find the distance, AB. We're going to find this distance here, AB. And what is that going to be? Well, let's try 3 minus 1 squared plus minus 2 minus 4 squared. And we're going to take the square root of that. And what do we get? 3 minus 1 is 2 squared. That's 4. Minus 2 minus 4 is minus 6. The negative number just, the negative sign just goes away, and we get 6 squared, which is 36. Remember, when we're squaring things, we can kind of drop the negative signs. So we get square root of 4 plus 36, square root of 40, and that's about 6.3 to the nearest tenth. So what did we do? Well, down here we found the endpoints by working backwards. And we used our midpoint formula. Even though we already knew the midpoint, we used our midpoint formula to find the x-coordinate for the endpoint. And we did the same thing over here. And once we had those, we used our distance formula to get the length of AB. There's a couple of nice ones where we get to use some geometry and our midpoint formulas. The question here is to find AM. And we're given that M is the midpoint on each of these. If M is the midpoint, then it's a bisector. If it's a bisector, what does that mean? It means that AM equals MC. So we can go ahead and finish that part off right here. Doesn't tell us much yet, but we know that that's true. So what does that say? In terms of setting up an algebraic equation, it tells us that x plus 5 equals 2x. Or, if I subtract an x from each side, I get x equals 5. Now, if x equals 5, put the 5 up here, and we get 10 for the length here. Now, don't stop there. That's all they asked us for, but we already decided that these two are equal. So if we got this right, this is going to turn out to be length 10 also. If this is 5, 2 times 5 is 10. So we can't stop. We got it right. Cool. What about over here? EM, this is a bisector. It's the midpoint. So we know the length of EM is equal to the length of MG. And what we have here is that 7x, if we set up our algebraic equation, equals 8x minus 6. So let's subtract 7x from each side, add 6 to each side, and get that 6 equals x. Does that make sense? Well, let's see here. 7 times x, if x were 6, put that in there, what do we get? 4 6 times 8, well, that's 48, minus 6, 40. Here's a good one. I like that they put these in here. It's good to look at common mistakes, and I can tell you from experience that the things these authors put in here are actually very common mistakes. They do a really good job at that. It's not that easy. So what's wrong with this one? Well, we have a midpoint formula that says, well, for instance, the x sub m, midpoint, the x-coordinate of the midpoint, is x1 plus x2 over 2. And what do we have here? Well, I think they subtracted here. And here we have 3 minus, oops, they subtracted again. So that's what's wrong. This should have been a plus, and this should have been a plus. So the actual answer would be 5. That would be 8 plus 2 over 2 is 5. And this here, well, this is 3 plus a negative 1, which is the same as 3 minus 1. That's 2 divided by 2, and that's 1. So the midpoint of these two is actually the point 5, 1, definitely not 3, 2. It's another example of something that you do when you're in a hurry, and you're probably trying hard to get to the next problem. And you do something just by rote really fast, and you draw a quick line instead of a plus sign. And then it's all over. You do all that work for nothing because you end up with the wrong answer. And here's another nice problem which illustrates the advantages of cutting corners. What we have here is existing roads, run this way, and then we have a road under construction that cuts across like this. Of course, the first question is, if we use the existing roads to go from B to E, how far do we travel? Well, that shouldn't be too hard to figure out. They put this on a horizontal line, so we don't even need the distance formula to compute this length here. This is, because they're on the same y-coordinate, you could say. That would probably be the easiest way to say it. For instance, the coordinates here of B is 1, 7. Now for D, the coordinate is 10, 7. And be sure to notice they put the origin over here in the bottom left. Frequently you're used to seeing it right here in the center. 0, 0 right here. Doesn't have to be. Everything here is positive, so they put it in the lower left. That always works just fine too. What's the distance from D to B? 10 minus 1. That equals BD. I think you can see the sense of that. The y-coordinate here doesn't change, so we just have to subtract the x-coordinates, 10 minus 1. Now here, well, they gave us another nice one. This here point D, as we say, that's 10, 7. And E is the point 10, 3. So here we have the same x-coordinate, and we just have to subtract the y-coordinates. 7 minus 3 equals 4. And that's DE. So we have BD, it's 9, DE, BD, DE. Bet I could write it right up here, I guess. That's 9, that's 4, So how far do you travel on existing roads? That would be 13 miles. Now suppose we use the new road. That's going to be a little different. First, what's BC? What's the distance over here? Because we're still going to have to travel this road here. Well, we already know that B is 1, 7. And it looks to me like C is the point 7, 7. Yes, 7, 7. So all we have to do is subtract the 1 here from the 7 here, and we get a length of 6 for BC. So what I really should have done was written, let's see here, that goes to there, like that, but from here to here, that is 6. Okay. That means that there's 3 units left over here, and we could count them up, or we could actually measure it. This is 10 here, the x-coordinate, the y-coordinates are the same. This is 7, 10 minus 7 is 3, so no problem there. But to stick with our distance formula, we should have 10 minus 7 squared. Here's 10. There's a 7. And to that, we're going to add. Looks weird to write from right to left, but I'm afraid I'll run out of room over here. Well, our distance formula would tell us to subtract the y-coordinates. Here we have 7. And here we have 3. So, just as we did before, 7 minus 3 squared. And that's the total. Pardon me, that's not the total. That's the distance from C to E. See how easy it is to get involved in computations and then forget what it is you're actually computing? This is going to give us the distance from here to here. We're still going to have to add 6 to that. That's not going to give us the total. That'll give us this distance. Then we'll see how much shorter it is when you cut corners. 7 minus 3, so we got 4 squared. 10 minus 7, we got 3 squared. And we want the square root of that. Well, this is 16 and this is 9. So we want the square root of 25. And I'm pretty sure that's 5. So this leg right here, this is 5. So if we cut corners, what do we end up with as a total? Over here we had a total distance of, there it is, 13. So we drove 11 miles. Down here, and we saved ourselves 2 miles by cutting the corner. Here's a nice one. I think it's always good to combine what you've learned before with what you're in the process of learning. That way you don't forget the previous stuff. Besides, in the end, you pretty much always end up having to use the stuff you used before. It's not like you have a whole lot of choices. Usually ends up being totally necessary. What we have here is point M is the midpoint of PQ. So let's start with a picture. That's always a pretty good idea. Let's see if I can draw a line. Well, it's close. That's a line segment. Here's P. And here's Q. estimate the midpoint there as m. PM is 23x plus 5. MQ is 25x minus 4. When we say M is the midpoint, what we mean is it bisects PQ. The length on this side has to be exactly equal to the length on this side. In other words, PM, and PM by itself means the length of the segment, equals MQ. So all we have to do is write down what we have in algebraic terms. 23x plus 5 equals 25x minus 4. And we know this is true because it's given that m is the midpoint. So what do we do with all this stuff? Well, suppose we were to subtract 23x from each side. And then down here we'd get 2x, wouldn't we? And over here we'd have 5, and we'd still have minus 4 over here. If we were to add 4 to each side, we'd have 9 equals 2x, x equals 4.5. But if this is multiple choice, I can just about guarantee that 4.5 would be one of the answers. You'd look up at it and see the 4.5 and grab it. And of course, you'd get 0 credit because this is x. Now we have to put x back in here to get the actual length. What is 23 times 4.5 plus 5? Well, let's find out. 23 times 4.5. I guess you should use parentheses there. It's easier to see. Plus 5. And what does that turn out to be? Well, this equals 108.5. Always check your work. If this is 108.5, this better be 108.5 also. Not only does it have to be true because m is the midpoint, but that's the way we set our equation up. So if these two don't turn out to be the same when we put our answer back in for x, we made a mistake. So what do we get if we actually put 25 times 4.5 minus 4? And guess what? You can grab your calculator and verify that that turns out to be 108.5. And here's one that uses some of the things you've already learned. Now you're hiking on a trail that lies along a straight railroad track. That's important because if you know it's a straight line, that helps. The total length of the trail is 5.4 kilometers. So let's sort of draw the trail here. There we go. And that's 5.4 kilometers. Now you're doing an average speed of 2.4 kph. That's kilometers per hour, of course. And you've been doing that for 45 minutes. Well, let's see here. That's the same as 3/4 of an hour, isn't it? Why do I do that? Because we have the speed in kilometers per hour. If I don't have the time in hours, it's going to be hard to end up with the distance. Remember the old distance formula? Well, this is one of them anyway, where you have, remember, distance divided by time is your velocity, or I should call it speed, since velocities, when you get to physics, you find velocity is a little bit different from speed. So distance divided by time equals your speed, or the distance traveled equals your speed multiplied by the time. These have to be in the same units. If this is in miles per hour, this has to be in hours. If this is in miles per minute, this has to be in minutes. And if this is kilometers per hour, this has to be in hours. That's why I did this. So we've got our speed is 2.4 kilometers per hour times 3/4. That is 3 times 2.4 divided by 4. That would be 0.8, wouldn't it? Like I said, that would be 0.6, wouldn't it? And 3 times 0.6 equals 1.8. That's how far he's gone so far. And they ask you, how much farther does he have to go to get to the end of the trail? Well, that's the whole distance here, minus what he has traveled so far. And we get 6 3. We have 3.6 miles left to go. I think earlier I said that it was good that it was straight. In this case, it didn't really matter. A lot of times straight lines are easier to work with, but since they gave us the distance and we can compute the distance traveled, all we have to do is perform a simple little subtraction to get to the answer. So it could have actually been a curved line and it wouldn't have mattered. Oh well. And you can always double check. Let's see, 6 and 8, 4. And 1, 2, and 3 is 5. Yeah, it all works. Well, that's it. We'll hope I see you next time. And goodbye.